structuring this morning is we're going to do an introduction to blockchain to get everybody level set. I know that when I attend things, it gets annoying when you are hearing things you already know. And so we broke it up intentionally so that we can have a level set so that everybody's on the same page. We'll take a break. Everybody needs a break every once in a while, right? And then we're going to take a deep dive into looking at blockchain and healthcare, which I think is why most of you are here. But like I said, it's always good to level set. So if you walk in this room and you are already a blockchain expert, you will in no way hurt my feelings. If you want to leave and go check email and work or whatever, we have lovely conference rooms on this floor. But otherwise, we'll just go ahead and get started, and we'll set the table for blockchain. So blockchain is a sort of colloquial word for distributed ledger technology. And when I give this talk, I break down each word. And this is a sort of famous photo to give you an idea where we are visually. We live right now in a centralized world. So Facebook, Amazon, all the big companies you know receive all of our data, all of our money, right? This is the world we live in right now. And then we're living through right now the consequences of living in a centralized world, right? When one person or one entity has all of your information, that can cause issues, right? Distributed ledger technology puts you in this dot, so this image that's on the right. And this is kind of blockchain utopia, so to speak, right? This is your peer-to-peer network. This is when everybody has equal access to the same information. So think about what that does from a security perspective, right? If you're living in a centralized world and someone gets into the entity that controls all of your, all of your private information, your money, whatever, that's serious issues. But if someone hacks or touches one of those lines that connects the dots, who cares, right? You don't have anything of value because everybody has equal access to the information. I say who cares sort of flippantly. I don't mean to be flippant, but it speaks to the security of blockchain technology and how that can be a huge benefit and a driver, especially when it comes to healthcare. The decentralized part of this gets into more of the nuances of blockchain technology and how it can be used. But here again, the point is people have equal access to the same information or maybe certain information. So when we give this talk and when we have this conversation, we're living in either this decentralized or distributed world, and we're outside the centralized world. So you have to completely shift your mindset. And having, like I said, been in New York and I went to these conferences, it was very strange to leave the decentralized world I was living in and get back to the airport and then get a piece of paper and have to stand in line, right? Because there's so much exciting things that can happen when you live in a decentralized world that we'll get to today. Now let's just hope I hit the right button. So now that we have a picture, literally, of what a distributed world can look like, we move on to the ledger, which is a little bit more complicated, but I promise we'll try and keep it high level. Again, this is I need to throw out a disclaimer because attorneys love disclaimers. I'm not a coder, right? This is a very high level talk. We're not going to talk about side chains and zero proof of work algorithms. We're not doing that. This is very high level. So again, we can all be on the same page. The ledger is a longitudinal, immutable record of time-stamped transactions related to an asset. Each one of those words has meaning and importance. So the longitudinal part of this is a record. Immutable is a fancy way of saying it cannot be changed. So when I've given this talk before, at the time, the Lego movie was out. And remember, has anybody seen the Lego movie or recently out? Okay, so if you have kids who've seen the Lego movie, President Business comes along and he puts everything with super glue, right? That's what blockchain is. He's president. Blockchain can be like President Business. Once it's laid and that's assembled, you're going to get lots of glue covered on it, and it cannot be changed. That's immutability. And I use a Lego reference because it is Lego. It's stacked. You can't undo the Lego once it's glued. That's the ledger. That's the promise and the potential and potentially the harm in blockchain technology. Time-stamped transaction related to an asset. I'm putting this up here. Well, the cryptographic schemes, again, I'm not a coder, so we're not going to leave here having developed a decentralized application. But all of this is based on very elegant cryptography. We'll get to the rest of middle. And the way I like to understand this, because I'm a pretty left brain person, is figuring out the variables and then understanding those. So there are two general, this is the most complicated part, we'll get into this, I promise. There are two general algorithms, generally, so for you coders out there, don't get mad at me. Two general algorithms that make blockchain work. The first algorithm we'll talk about is the proof of work algorithm. And I think the best way to describe this is through an example. So, and proof of work, by the way, is what underlies Bitcoin. And we're not going to talk about Bitcoin today. We're not talking about cryptocurrency, so we're not going to have, you can have that conversation on the break. But it's important for you to understand what proof of work algorithm is and what it does. But this, again, is the algorithm that underlies cryptocurrency. So here we go. We have Frank. He wants to pay Anna with Bitcoin. So he has a wallet installed on an app, which is his wallet, installed on his phone. And because this is all based on cryptography, again, this is maybe complicated, but you have a public key and you have a private key. The private key is yours, just like the keys to your house. The public key is like your address. This is where I live. So you can tell everybody, you can know the public address or public key, but you can keep your private key private. So Frank has his private key. He knows Anna's address and her public key, and he's going to initiate this transaction to send money to Anna. What blockchain technology allows you to do is if you say, I have $100 million in my bank account, I'm going to send 99 million to Anna, and then 99 million to somebody else. Blockchain technology allows you to go into, it knows how much you actually have in your bank account. So one of the benefits to this is there's no double spend problem. That's one of, you'll hear this, and you're nodding, this is great. Okay, so once that happens, once this transaction is initiated, this is the confusing part, but you initiate just like you do a transaction on the web, and it goes out, and miners pick up the fact that you want to engage in this transaction, and it goes through this complex computational cryptography equation, and it solves the public-private key to show that Frank actually has the money he wants to pay Anna, and that Anna is the right place, and that's a transaction that is recorded and initiated, and once it's solved, it's put into what is a block, and all of that, or that transaction's recorded, and the multiple transactions are grouped into a block, okay? Each block refers to the block before it. This is the Lego analogy. So so this is why I like to stand when I give this talk. You're just block after block after block after block. And once this computation happens, and once that happens, and I'm getting all confused. I'm jumbling up these three slides, these 3 points. But once that complex mathematical equation is solved, again, it links into the next block. That happens every 11 minutes, and the transaction is recorded, and it goes through. That's it. I didn't do a very good job in this part, but does that make sense to you? Because it's hard. That's it. You're initiating a transaction, it's grouped all together, it refers to the block before it, and once it's recorded, it cannot be changed. So a term I've just heard is garbage in, garbage forever. It doesn't necessarily apply to this because it's going to be a transaction of money, right? But think about the implications of that. Again, this happens every 10 minutes, and you can see what happens. This is all public. When I first heard about this mining stuff, miners, I imagined a guy or a person, woman, whoever, sitting in his parents' bedroom who loves math and solving mathematical equations, right? So I quickly learned, though, that's not that the case. This is a miner. You can buy this machine. And the reason, this is the best part, going back. The way mining works, this complex cryptographic equation is solved, and the reason you want to do this is because once you solve that equation, you get a reward. So everybody who's mining for cryptocurrency gets a little fraction of the cryptocurrency as a reward. That's exciting. We all love to be paid, and we all love to receive rewards, right? So that's why you hear about mining and mining machines, right? And so again, this is a mining machine. And some people mine. You might hear about them or see them or read about them. And the reason you're not gonna all quit your day jobs and start mining is because there's immense power and electricity that is used to make these machines work. So you'll hear about mining operations in places like Wyoming and Montana because it's cold. Siberia, they have really robust mining operations because these machines get to stay cold. It reduces the power that's used. And then it's all public. So that's another exciting and good thing, right? So, well, sort of. This right here, you can't see very well, but these are all of the public sort of, well, this is all public. And this makes no sense. It's all gibberish. It's a series of letters and numbers, and it doesn't make any sense, and it's not supposed to. But you can see what happens to your Bitcoin as it's going through the world. So what's also cool about that is so you can track Bitcoin. You can't track all the cryptocurrencies, but if I gave you 10 Bitcoin, which would be a decent amount of money, I can see how you're using that down the line in theory. This QR code lets you track and see that your Bitcoin is going where you want it to go and that the transaction happened. Yes. Because of your public-private keys, there's no, so okay, the anonymity part and the pseudonymous part get confused. Nobody knows that that's my private, I'm gonna keep my private key private, so no one's gonna see my private key. No one's gonna know that that's linked to me because I'm keeping it secret, but they'll see my public address. Okay, that's proof of work. There's a reward, right? There's a machine involved, okay? Are we good there? Okay. The other algorithm is proof of stake. Here, same thing, there's a transaction that wants to happen, and here I have a health record, which is kind of a utopian vision, but let's just pretend it's some kind of data that wants to be transferred from one person to another. Same thing, you still have your public and private key pairs, but instead of a mining machine solving this complex cryptographic equation, you have a network. Remember, think back to the first slide, you have that network. It can be a peer-to-peer, every dot connected, or you can have a certain permissioned group of people that are going to agree or not that something should happen. And that can be captured in a smart contract. I love contracts. I do contracts in my job. Smart contracts are not really contracts at all. Smart contracts are a set of code, and it's basically a set of if-then statements or conditions precedent, right? So if your name is Kristen, if you actually have a record, or you're going to have this consensus mechanism so that transaction can take place. I'm pausing for effect. Same thing, once the transaction is initiated, it gets recorded in this immutable ledger. It's time-stamped. Once it's recorded, it cannot be changed. It references the block before it. You're going down the line. It cannot be changed. It happens I don't know how fast it can happen because it depends on the smart contract. And that's how a transaction happens using blockchain technology that's outside the cryptocurrency world. You're nodding. This is fantastic. This is it at a high level. After this, you can see all of the things you can do with a blockchain. I love this slide because it's a little bit messy. And I like this messiness because there's so many options and so many things you can do with blockchain technology. We're obviously here to hear one application of it, healthcare, but these are different sectors and things that people are looking at in connection with blockchain technology. And there are use cases that we could talk about in connection with every single one of these little circles. And at this point, this is where I kind of end, because I was hoping you guys would have questions, but you're either so lost, you don't know where to start, or you're like, yeah, I got it. I'm hoping it's the latter. So we'll make the break a little longer, and I'm gonna go ahead and say this. Part of adopting and incorporating blockchain technology into our daily world is all driven by human behavior and how we're going to change maybe the way we work or the way we live to create that more decentralized structure. This relates to human behavior and creating that incentive structure, just like they did with Bitcoin, right? They created the incentive structure in mining, right? So part of this event, of course, is to educate. But the other thing we were hoping to achieve is for everybody in this room who's interested in blockchain technology, you all are like-minded in this way. And I want you to meet each other, okay? So in the spirit of blockchain technology, go ahead. Well, let me finish this, okay? in the spirit of blockchain technology and incentivizing people to change behavior and maybe get outside something that is a little unknown, we're going to have a little bit of a contest, because the proof of work algorithm, again, is that incentive, right? And so we are incentivizing you to maybe get outside your comfort zone. And we want to, again, to meet people. So what we're going to do is have a little bit of a contest, and whoever at the end of this event collects the most business cards is going to have a choice to win either an Echo Dot or a bottle of Jack Daniels. Okay? And I will say that this idea came about because of the conferences I attended. A lot of this, again, is changing behavior and getting people to think in a different way, right? And I played Scrabble, and they changed the Scrabble game enough so that the players, we integrated a proof of work algorithm in the game of Scrabble. And I will not get into that because that's a whole different talk, and it was very confusing, but it was very cool. There's also a website called bounties.network, and that's what it is. It's incentivizing people to change behavior or do something to get a result that you want. So for example, they're putting the bounties up on a wall. One of the bounties was, I want my garbage disposal changed and I live in Queens. That's easy, that's like a crowdfunding thing. Someone said, I want everybody to stop using plastic, right? So that's harder, right? And a little bit, some of it's outside of your control, but if you could show that you were trying to achieve the result you're trying to get, you would get ether. You've incentivized people. So with that, meet and greet, and we will continue this conversation in a little bit.